To understand more about plate tectonics and continental drift, we have to look deep inside the Earth. The Earth's interior consists of several different layers. The inner core, which is believed to be solid iron and which is very hot. The outer core, which is believed to consist of rocky material so hot and under such great pressure that it is in a liquid state. The mantle, which is not as hot as the outer core and not as liquid. The mantle's outermost portion is solid. This is the solid outer portion of the mantle. Above this is the outermost layer of the Earth, the crust. Together, the crust and solid outer portion of the mantle form the Earth's outer shell. They are referred to as the lithosphere. It's not always easy to see the Earth's crust. It's covered by vegetation and the oceans. But if you could drain the Earth's oceans and strip away our planet's vegetation, the Earth might look something like this. Now we can see the Earth's hard outer shell. And if you look closely, you can also see the shell is cracked. The red glowing lines mark the places where the Earth's shell is cracked into tectonic plates. Each plate carries a continent or an ocean basin, or sometimes both. The plates are moving at an average rate of 1 to 2 inches a year in a variety of directions, carrying continents and ocean basins with them. Here's why the plates are moving. Scientists believe material in the mantle is circulating much as it is doing here. The movement may be caused by heat within the mantle. You can get an idea of how heat can cause a circulating movement by watching rice as it boils. What you see happening within this beaker is similar to what's happening within the Earth's mantle. As mantle material moves, perhaps only inches a year, it causes the plates above it to move as well. In some places, plates are moving in opposite directions. They are moving apart. The area where two plates are moving apart is called a divergent boundary. In other places, plates are colliding. The area where two plates are colliding is called a convergent boundary. And in other places, plates slide past each other. This area is called a transform boundary. This is a cross-section of a divergent boundary, the mid-ocean ridge, located beneath the Atlantic Ocean. The North American plate is on the left, and the Eurasian plate is on the right. Scientists believe that as the plates move apart, mantle material called magma rises to fill the gap. Magma is the name we give lava before it erupts from volcanoes, as it is doing here. The magma cools and hardens on the ocean floor, adding new crust to old. And as the seafloor spreads, North America moves farther away from Asia. The highlighted area on this globe shows where magma is surfacing between plate boundaries beneath the oceans, creating a mid-ocean ridge that circles the Earth. The ocean floor spreads in one direction on one side of the ridge and in the opposite direction on the other. The mid-ocean ridge is where plate material is created. And this is where plate material is destroyed, a convergent boundary. In this cross-section, the plate on the right is carrying an ocean basin and is moving in this direction. The plate on the left is carrying a continent and is moving in the opposite direction. The plate carrying the ocean basin is heavier and is diving beneath the plate carrying the continent. The leading edge of the diving plate is consumed back into the Earth's mantle. When one plate dives beneath another, it is called subduction, and the area where it occurs is called a subduction zone. Subduction may resemble what is happening on this lava lake as sections of hardened crust dive beneath other sections. The highlighted areas on this globe mark convergent boundaries. Subduction is occurring at most of them. These are the areas where plate material is destroyed. Here again are divergent boundaries, where plate material is being created. Again, most of them are beneath the oceans, creating a mid-ocean ridge that circles the globe.